Hey everyone, Mr. H again. Going to continue with 8.3. This is page 3. Some more examples using forces. So here we have, I'm on example 2, two forces of magnitudes 284 newtons and 325 newtons act on a point. If you haven't seen newtons before, it's a unit of force that equals about 0.225 pounds. So you'll see that a lot in physics. And then we're given the angle between the two. So it always helps to draw these. So let's put the 325 going horizontal, something like that. Okay. And then at a 108-degree angle, we have this force going up that way, right? It's not really, it's not entirely to scale here, but close enough. Okay, so there's my picture. I want to draw my parallelogram. Okay, so I like to use yellow or dotted lines. So let's go try to draw that. And then that. Okay, it looks like a parallelogram. And then the resultant force is that diagonal of that parallelogram, starting here where they join or they start and then ending over here. Okay, like that. Okay, and we need to find the magnitude of that angle. So we'll call V again, right? And it's helpful to find this angle here, because I know that down here we have 325. If this is 284, that's 284. Those are the same. This angle right here and that angle should add up to 180. So 180 minus 108 is 72. So this angle is 72, and then I got side, angle, side. Side, angle, side, law of cosines, just like in the previous problem. I'm going to have v squared equal to each of those sides squared minus 2 times each of those sides times the cosine of that angle that's between the two sides. All right. Calculating that out, let's see, that's about 12,900, 129,236 point, I don't know, whatever. Okay, so that's the V, that's the magnitude squared. Now I'm going to take the square root of that. Let's do this. Square root of this number here. All right, and then I'm going to calculate that. Let's see what we get here. Calculating that, I'm getting about 360. So, well, these, for some reason, I didn't put what to round to. So, and that's in newtons. We'll just go 359.5. All right. And that's it. That's what we wanted, the magnitude of that, and we're good. Okay. Okay, so not too bad. How about this one? This one's a little different because it gives you only one of the magnitudes, and it gives you a couple of angles. So a force of 162. All right, let's draw that force of 162. Let's do it down like that. All right, 162 pounds makes an angle with a second force of an unknown magnitude, but we know the angle. All right, and that angle is this angle here, 78 degrees. Ooh, it's and it's 50 minutes. Okay, remember that stuff, 50 minutes. All right. And let's just call this force W. All right. And then we know there's going to be a resultant. So I can make my parallelogram. That one didn't really line up. Okay. And I like, for some reason, doing that in green. All right. Okay. There we go. There's the picture. And then we know, okay, the resultant of the two forces makes an angle of 38 degrees 6 minutes to that first force. So that's this angle down here, right? 38 degrees 6 minutes. Okay, so we got some geometry to do of finding angles here. And then we need to find the magnitudes of both the second force, the W, and the resultant. Again, let's call V because that's what we've been doing. All right. So what's going to be helpful on this one is if you find all of the angles in this triangle down here. All right, let's find the angles in that triangle. Okay, so first thing I'm going to do is a 180 minus that 78 degrees 50 minutes, right? That will give me this angle right here. Okay, because this angle here and this angle add up to 180. And then this is going to equal, when I do that subtraction, a little review from when we did this back in chapter 5. Think of that as 179.60. Right, do like a little borrowing thing. And that's going to be 101.10, right? So that's this angle, 101 degrees, 10 minutes. Now that third angle up here, I'm going to need to solve this triangle. That is a 180 rule on this triangle down here, right? So then 180 minus 38 degrees 6 minutes, and then minus the 101.10, right? And again, think of that as the 179.60 minus all that stuff. So then you can subtract degrees and subtract minutes, right? So do 179 minus 38 minus 101, and that is 40. And then 60 minus 6 minus 10 is 44 minutes. So that's that angle up there, 40 degrees, 44 minutes. Okay, so we got the picture right. All right, it takes a little work to get that picture right, but once you have that, then you're in good shape. Okay, so that was a lot of little scratch work to get those angles. Let's kind of shrink that down and get some more room. Put you right there. Okay, next, what do we want to do? We want to solve this triangle because I want both V and W. And if W is over there, W is there as well, right? So notice what we have here. We have angle, side, angle, right? Angle, side, angle. Angle, side, angle, I can use law of sines. So law of sines, let's use law of sines to find V or W, it doesn't matter, right? So let's go with W. So the magnitude of W over the sine of the angle opposite that, which is 38 degrees 6 minutes, which in my calculator, I'm going to write it like that, 38 plus 6 divided by 60, and then equals, let's see, we have the 162 is known, that magnitude, and the angle opposite that is the 44.60. Okay. And then cross multiply, divide by the sine of 40 plus 440, 44, 60, whatever. All right. When we do the algebra, that's what I'm trying to say, I'm going to get 162 sine of that stuff divided by the sine of the 40 stuff. Okay. That's what I'm going to put in my calculator to get W. When I do that, I'm getting about 153.186. And that would be in pounds. Or rounding to one decimal place, say that's 153.2 pounds. All right. Cool, and we got the W. The last thing to get is the V, which I could use now, law of cosines, or I could use law of sines again. Doesn't matter, whichever one you would prefer. Maybe law of sines would be better because you don't have to use this rounded value. But as long as you use like some extra decimal places, you'll be fine with law of cosines. But let's just do law of cosines, because it's just nice one line, less room. It's kind of less work. And it's about equivalent, but we're going to go with it. Okay, so the magnitude of v squared is each side squared. So if I'm looking at side, angle, side now, right? 162 squared plus, now on my angle, I'm going to use the 153.186 squared, right? Minus, well, let's kind of run out of room here, but minus 2 times each of those times the cosine of the angle between them, which is the 101 plus 10 divided by 60. Okay, there we go. Squeezed it all in there. Check out the completed notes. It looks nicer there. Okay, this is about 59,321.9146. And then you just have to take the square root of that to get the v, right? So v square rooting that number is about 243.6 pounds. There we go. All right. Okay, let's try one more page. One different type of example are these inclined plane problems. The nice thing about these, a lot less work. There's no law of cosines. It's all right triangle trigonometry because we have a right angle involved. But basically, you have this 50-pound wagon and it's sliding down a ramp. Assume there's no friction and the ramp's incline is 20 degrees. What force parallel to the incline, right, which is right there, what force is required in order to keep that wagon from sliding down the slope? Well, it's a little bit of geometry to start this off, because, and it's written in the diagram already, but if this is 20, then so is that angle right there. Okay, because if that's 20, that's the supplement of 20, which is 70, and then 90 minus 70, you're back to 20. Okay, and by the way, the forces, there's all these forces here. The one going straight down, that force is the weight of the wagon, right? Weight always goes straight down, force of gravity. This force is the weight exerted on the ramp, perpendicular to the ramp, okay? And then that force is the force required, which is here, right? So you do have this kind of parallelogram going on. Let's erase all that because I just made it a big mess. All right. Okay, so really your focus then is on that triangle. Notice it's a right triangle, the one with the blue sides, right? And you have a hypotenuse that's 50. There's the hypotenuse, right? And we're trying to find F, which is the same as this AC down here. Right? So it's, and that's opposite the 20. So the AC is opposite and the 50 is the hypotenuse, that's sine, right? So sine of 20 degrees is equal to opposite, which is the magnitude of F, or also magnitude of AC. Those are the same. Divided by the hypotenuse, which we know the magnitude of that is 50. All right, so my force algebraically multiply both sides by 50, and I've got it. I just got to calculate that for my final answer. See, not a lot of work. That's about 17 pounds. Okay. You can almost think of this as a little formula, which is helpful on these. This is always the weight of the object that's on the incline. And this is the angle of the incline. Okay. This is the force required to hold it in place. That helps in a problem that maybe gives you some different information, right? So here you know the force required and you know the weight, what's the angle, right? Well, you can do that same structure. The force required is 16. So that's the magnitude of F is 16. The weight is 40. And the angle is unknown. All right, solving for that, just divide both sides by 40. All right, so 16 over 40 is equal to sine theta. To get theta, then that means you're going to have to do sine inverse of 16 over 40. And that's going to be the final answer. That's 23.6. Okay, and that is it. All right, so that's a good stopping point. We'll do one more type of example on navigation in the last video, and send my questions my way if you have any. Hope all's well. Bye.